I'm going to show you guys the agenda here, and preparing for a conference here. So while preparing for this conference, I actually had quite a few new slides created, and I want to share them with you. So here we go. This is the new material. So first of all, intros and updates. My name is Chris Fregley. I worked for Databricks and Netflix. Netflix was my first job in the Bay Area. It was the reason I moved from Chicago to the Bay Area. I worked at the IBM Spark Tech Center for about a year and built that group up from 5 people to 65, specifically in the context of Spark, which was really fun. I got to meet a lot of great people, and yeah, like super exciting stuff. It was fun to work with those Databricks guys kind of on the other side of the Databricks firewall and help IBM get more focused on Spark. IBM has since actually created more of a neural network type of group so that they can include things like TensorFlow and MXNet and some of the AI stuff that IBM is also working on. I'm founder of the Event Spark TensorFlow Meetup. A lot of you guys probably found this event through that meetup, so that's great. Those channels are working. We've got about actually close to 100,000 people signed up now across the world. So I see lots of people from all over Amsterdam and Spain and some other places. So that's very exciting. Love the growth and love the excitement around this stuff. And if you guys ever need me, Chris at PipelineAI. There's actually easier way, or actually better ways to get a hold of me. You can go through our website, and there's a little pop-up thing in the bottom right. That's really the only way to get truly a hold of me. Email's a little bit slow these days. We're more of a real-time company, so we like Slack and we like other kind of faster channels, director channels than the asynchronous email. So we also have a big YouTube channel, SlideShare. You can get all to this if you go to pipeline.ai. We'll have everything. I want to set the context and say, kind of what Pipeline is, where, some have called us PipelineAI as AI best practices in a box. And, this is kind of a silly term, but if you take a look at some of these other powerhouses in AI, the Facebooks and Uber and Netflix, these folks cannot operate without their own platform, without a platform specifically meant for this type of workload, for the machine learning AI workloads. And this is because these kind of things really go outside of the standard, continuous delivery, continuous like integration from normal microservices. So here we have cases now where the code that you put out can degrade over time and can very quickly degrade over time. And that's really what these frameworks and platforms have been put in place for. In fact, there was a recent job listing that my old boss from Netflix actually filled, and it's Director of Machine Learning Infrastructure, and it's exactly, if you read it, it's pretty much exactly what Pipeline does. So while we're not out to replace people's jobs, and we're not, certainly not my old boss's job, what we do want to do is bring these best practices to the masses, and really, not just democratize machine learning like everybody's saying, but really democratize machine learning in production, and that's our focus. And so you'll see a lot of the research and a lot of the features we built, even since the last update last month, are very in line with this, very in line with our core principles of continuous continuous training, continuous model optimization, continuous model validation, and continuous model explanation. So model explainability is a big part of machine learning going forward. There's not a lot of people doing this, and we've got a part of the platform. So we'll show you how this works here in a bit. So the core problem here is that current applications, the current machine learning frameworks have been designed what we're calling sort of ML 1.0 and ML 2.0. So these have really been designed for the research side of things and not for production. So, planning and training, and that's all kind of where things are traditionally. There's this step that some of the advanced shops have that's called pre-production. And not many people really even know about this phase, but this is kind of the handoff phase, it's called, when people the data scientists who are skilled in statistics and variances and like typically come from a physics background and are very good with fuzzy type of like calculations, now have to get this thing onto a system that is very deterministic, that enjoys being able to optimize, and so hardware and the software and these algorithms are very, very different skill sets, number one, but they have very different goals. So while the people on the planning, on the modeling side are very much into, let's try to increase accuracy and let's make, cut some corners here, or do some things to try to improve accuracy. Really, the systems people, they're all about trying to get the best response time, and really, trying to lay on top the algorithms that have been presented that are written in Scikit, written in R, written in MATLAB, and to try to get those into C, into C++. These days TensorFlow Python is very powerful. It's not so much the Python part as it is it's like the underlying C and like GPU kernels that back this Python code. And so what you'll notice is that there's a big chasm between that whole area, and not just in knowledge and skill set and focus, but the goals are quite different. And so as things go to production, when I say production here, I mean application level production, right? So depending on who you talk to, if you talk to a pure data scientist, their version of production is pointing their queries or their training at a very large S3 bucket, versus just using a sample of the data set on their laptop. When you talk to the application developer or an ML engineer, their version of production is heavy code generation, multiple variations being generated so that we can test. And this is what really gives people the advantage, gives companies the advantage in this new ML 3.0 world. So fortunately, frameworks like TensorFlow and like MXNet, they are production first, and they actually do things during training time that help with that production first thinking. So really, this is very linear right now, is my point here. And then also these models decay. There's hardly any feedback when people hand off from this pre-production. And the traditional data scientist on the left tends to completely lose visibility into the models after they've been deployed. And so all of the accuracy and validation and all of the traditional things that these data scientists have access to offline, keep in mind that's on historical batch, slow moving data. And that's really where you want to, what you want to do is spend more time keeping an eye on the current data and, capturing current trends. Now, this isn't for all use cases. There's quite a lot of folks that say, well, this is, too much engineering for my use. So just bear with me here and I'll show you some other, fun things that you can do when you really buy into this production first, AI first way of thinking. Okay, let me show you just one more slide here, and I see some hands being raised. So the core problem back here is that this is very linear, and there's a handoff period, and each side kind of does their own thing. There's no one really in the middle there that can sort of give you choices for accuracy versus throughput kind of thing. So let's talk about PipelineAI solution. So these modern applications really require these ML 3.0 frameworks that are designed for production. And so the 3 points, there's actually one missing here, but continuous training. So this is the ability to, even after, so think of the current training and the current production. These are two separate worlds. If you can continue to train your models in production, this is very, very powerful. Now, there's downsides to this, and there's constraints that you want to put on this so that you're not capturing too many local trending things. You want to have a nice anchor back into the historical batch, but right now, the options to even try this or to use this type of like workflow are very limited. These are very complex, like infrastructure setups. You know, there's Kafka streams involved, and there's like lots of, you know, like rate limiting and sampling, and so these are the things and the knobs that the pipeline framework is focused on to make this easy for you. So continuous training, that's one part. Continuous validation. So think of when offline you do a training run, you look at the accuracy, then you do the validation run, also look at the accuracy, and then that's where it ends. With pipeline, this is continuous, and this feeds back into the offline batch world. So throughout the life, the like running life of this model, if this model is running for 6 weeks, we are constantly checking and validating it against the ground truth. And you know, ground truth here is not a very light topic. This is a pretty serious topic to figure out. How do you determine ground truth on unlabeled data? And really the only way to do it is pretty much the same way that you do it today, which is every 24 hours or every 2 months you run a Spark job that can then label that data and say that you know, either this person or this group of people that saw this variance of the model, they like converted 80% of the time. This other group converted 5% of the time. You know, these are made up numbers, but so some of these use cases can actually be sort of like labeled on the fly, but that's not often the case. So updating online accuracy is a bit more complicated, but again, you know, we come from Databricks and from like IBM. We have a lot of the enterprise experience to like kick off these Spark jobs. My project with Databricks was building something similar to this, but for offline, you know, batch machine learning. And so we're just taking that knowledge, pulling it in. And think of the ability to introduce a hook into the platform to perform this type of like labeling, if you will, or, you know, to surface this ground truth and to continuously, you know, if it's every 24 hours, if it's every 4 hours, add a label and say whether or not this model is still as relevant as it was when it first went out. If the model wasn't, you want to have alerts set up similar to how you would have any kind of systems, you know, type of alert, except this is more of a predictive performance alert and not a systems type of alert. Continuous optimization really is, you know, when you validate, you're actually measuring. So, you know, training, then you're validating. When you can't optimize unless you can measure. And so once you're now able to continuously measure, now you can continuously optimize. And this data then also gets sent back in to, you know, things that you learn here get sent back in to the traditional training, you know, batch offline training, gets picked up either from the Kafka streams that are feeding this TensorFlow job. This is one of the demos we have here. And then this whole cycle starts again. So the whole rest of the world right now is in this offline part of the yin yang, and we're in the black side there. So that's kind of, you know, fancy marketing term to put it there. Our mission statement, very bluntly, is we want to own the model prediction runtime. We want to, you know, not own it like a monopoly or anything like that. We're not interested in that kind of economics, but when you can own the model runtime, when you can, you know, think of it like the old BEA systems and BEA WebLogic, right? These were middleware projects and like products that allowed you to not have to think about a lot of the kind of gory details of garbage collection and of, you know, jar file packaging and all that stuff. They just did this for you, and you hooked into these platforms. So really, this is what we're all about. And not like coincidentally, but I actually worked for BEA Systems back in the day, back when they were going through the tornado of this, you know, huge motion. Lots and lots of, you know, sales folks being joined at the same time and pulling in their friends and, you know, really owning the space. So I was part of that wave, and BEA was always featured by Jeffrey Moore and some of these books, Crossing the Chasm, some of these, pretty revolutionary, like business books about how software is, changing things quite a bit. And so I'm really excited to kind of re-implement that same style and really target the runtime. Once you target the runtime, we can now inject in explainability. We can now inject in very complex comparison dashboards. We can now, do lots of analysis in real time, right? There's some of you that might be thinking, well, I could do all this stuff. I just need to collect all the data, run the Hive job. The job takes, 14 hours, and then I have the data. And that's fine. You could still do that, and that's how lots of people will do it. And sometimes it's even tough for people to understand why our process or our product is better than other. And that's one of those things where if you don't get it right away, it's probably because you haven't internalized the type, or you are not aware that there is a better way to do this. And that's really what I've spent the last year, year and a half trying to surface. And really when seeking product market fit for this product, I've been engaging with you guys. I've been getting feedback from you guys constantly. I get emails, I get Slacks, I get all kinds of stuff saying, hey, this is actually a real need. Please come talk to our team. Typically, these teams have already built something like it, but they don't want to maintain it, or they're missing a key feature like the continuous training, and so that's where they want us. So I've been very fortunate to have a pretty solid network, especially in the Bay Area where things move at lightning speed there. So we've really been able to work with some of the best, and you'll see that back here we actually have a guy from Uber just joined the advisory board. Super excited about that. He's been giving us a lot of good info about Michelangelo and how that was designed and what could have been designed different and the types of use cases that Uber sees. And it's not like we will ever replace Michelangelo, but if we can track along and do some things different and do some things that are a bit more general than just the Uber use cases, then this is really, really beneficial to everyone that's involved. So also there's this other company, Cloudflare, and I've actually been using them for our app quite heavily. And if you're not familiar with them, they essentially are becoming middleware for web applications. And this is kind of silly, but think of the ability. So we just did this over the weekend where I needed to scale out my app or our servers today for today's webinar, and then also a huge conference that I'm speaking at here in a couple hours. And with just one or two clicks, I was able to get in some pretty advanced load balancing strategies and without changing my app at all. And this very much reminds me of my BEA days when I was onboarding customers and seeing them not have to make many changes, but all of a sudden get the transactions and get good clean garbage collection and good dependency management, and with just some simple annotations. And so Cloudflare is actually doing this. They have this tiny little marketplace where you can add apps. And it's little snippets of it's just little snippets of JavaScript and CSS at the end of the day, but it's code that you don't have to write, that they can intelligently inject into every single request response. And it just hit me just the other day that's pretty much exactly the same thing that BEA did and that we're doing now with machine learning. So let's see. I just want to give you guys kind of a hint of global traction. The numbers are, well over 100,000. So we have lots and lots of interest. This is just kind of a loose breakdown. The last we looked at, I think this was GitHub, but then also some of our, mailing lists and current registered users. So, kicking butt in North America, actually quite a lot higher. I've never even been to Latin America, and we're kicking butt over there. So I have to convince my peers to let me go there. Yeah, I try to visit and see that area, eat some good food. Here's some extra features. Secure private enterprise hosting, all that stuff, multi-cloud, hybrid cloud. The key here is being able to push out these experiments quickly in production, right, and safely. There's been so many times when we've heard people say, oh, if we only had Pipeline, we could have compared the version that we were about to put out safely on live data, and we then could have avoided this, 7-hour outage because we propagated the new model to all of our servers, and there was no way to cleanly roll back. And coming from Netflix, these are things that are just completely like barbaric to, when you see it done well, and you see the best practices, and you see how quick it is to like roll back in these, situations, you just kind of take it for like granted. And then when you speak to people, they're like, yeah, we have nothing like that at all, or it's really janky and it takes, like 2 days to actually unroll everything. So we come from Netflix. We think of failure. That's one thing that gets beaten into you day one. Is any job you've had like before that where you were excited about all the happy paths, you spend about 5% of your time building and like architecting for the happy path, and you spend 95% time like architecting for the failures and like testing the failures. Also, I just want to make it really clear that we could do prediction auditing down to an individual prediction. Now, this is huge. This comes up in healthcare. This comes up in, on the explainability. And like most people would say, well, why do I care about the individual prediction when really we're looking at aggregates? And yeah, that's absolutely true. Some people and most people are looking at aggregates, and really that's the level, that fills a lot of use cases. But there's a whole new set of these use cases coming down, onto our development plates that is going to require down to the individual request to show me which predictions were involved, which features were passed in, which parts of the neural network actually activated that part of the prediction. And this is hitting us pretty quick with GDPR. And, if you continue to operate at the sort of summary statistics level, you're going to be spending quite a bit of development time trying to back into the individual. Whereas we start at the individual, and then obviously you can back in. It's a lot easier to aggregate data when it's stored at like the individual level, much easier than when you only store the aggregations and then you have to back in, and it's the classic fission versus fusion type of thinking. Okay, I also want to make it clear that this is very broad, so we support these features across TensorFlow and Scikit and R and SparkML, and yes, MXNet's on here. I think we have a slide somewhere with all the different. We got XGBoost. We just added samples. We're adding samples every day. If you go to our site, you can actually follow along. The community edition has all that stuff. So. Okay, since we last talked, we have an improved UI. Spend a lot of time on usability and just showing this to our friends. And, I'm always crazy about getting the app to work on my cell phone. If it doesn't work on my iPhone, then, to me, it's not a usable app. It's not completely usable yet on the iPhone without having to scroll quite a bit, but we're getting there. We're learning this stuff as we go on the UI side. But the good news is that like folks like you give us a lot of feedback, and so we've been rolling all that in. We've got request tracing explanations, continuous training, validation. We also introduced bandit-based traffic auto routers, and so with any good platform, you have hooks into that framework or that platform. And we're not going to limit you in like any way. We want to give you the rails and let you build the trains and all the things that you need to keep your system moving. So like one of the first sort of manifestations of this design and this architecture is the ability to create a function whose sole purpose is to take in the current state of all of the services that are out there, all of the model variants, for example, for one experiment, let's say, or across all experiments. And then using multi-arm bandit techniques, you can then choose which model we should start sending more traffic to. Which one is an early winner? How far into the experiment are we? Can we end the experiment sooner than we thought? So these are just functions that you inject, and when you define the auto router, you then so first create the function, then you can wire it up to the auto router, and then you're not manually routing traffic anymore. You're actually routing it automatically. The system is doing it for you, based on the objective function that you've put in there. If the objective function is cost, then we encourage you and have examples to take a look at the current cost metrics, which I'll show you here. Yes, every request that goes in, we are calculating the cost for that request, which really comes down to the cost of the instance itself, and then how much processing time did it require, and pretty easy stuff. So NearTerm Roadmap, we're going to be surfacing our streaming stuff a bit more. Right now it's kind of behind the scenes for the continuous training. Integration, more like integration with these Spark jobs, like I said, for the ground truth calculations of the continuous model validation after these models have been deployed. We'll be setting up the alerts too and stuff. That's not on here, but just had a conversation about that, where you could set up alerts for if the predictive accuracy online dips below a particular threshold or relative to 1 month ago, where it was at 1 month ago or 1 week ago, we could actually flag that and request either a retraining event to get it caught up and to improve, or request that a new model be trained and then rolled in safely through the existing system, where we put the new model aside, the current model, we shadow some traffic, we make sure that they're not too far off or that the new one's better. Might take 24 hours to do that sort of ground truth assessment. The core thinking here is that no matter what you do offline, no matter how good or bad your models look offline, there's really no way to tell until they go online. And that's exactly how Netflix rolls, and that's the type of platform that we're bringing to you guys. Focus more on the ensembling features. So right now this is in its kind of first generation, where you're able to select other models and join them, and then you can provide a custom aggregator. So when you get the results back from, let's say you're firing off 2 model predictions in parallel, and what do you do with the results of these model predictions? Do you add them? Do you divide them? Do you ignore them if they're too far off? Do you wait for a majority to come in if it's a classification? Do you need 3 out of 5? You need 5 out of 7? More visualizations. These are always nice. So we're coming out with these left and right. We've got some cool ones that we'll show you here in a sec that let you actually visualize the input, visualize the prediction, and compare across multiple models that are receiving the same inputs. And that would be specifically in our mirroring mode, where we're mirroring traffic and shadowing traffic to these other models. We're also planning a huge community event using TPUs. This is actually going to be a part 2, thanks to those of you who were on part 1. We've got the proper scale now in Google Cloud. We had some issues there where we had enough TPUs but didn't have enough CPUs to power those TPUs. So it was an area that was a bit of oversight on my part, and we had a lot more signups than we thought, so we couldn't just kind of fake it. But yeah, so that'll be coming up. That'll be sometime in August. So keep an eye out for that. Keep an eye out on the Meetup, or whatever channel you have is where I'll be posting all this stuff. So if it's Eventbrite, keep an eye out there. Yeah, mention the adaptive traffic routing. That's the bandit stuff. And then really, all of this is leading to this concept of online real-time hyperparameter tuning. And not only are we exposing more hyperparameters to tune, because we have knobs that have never been turned before. We have knobs for the runtime, and we have knobs, and the runtime being either TensorFlow serving or our custom pipeline like runtime. We're also adding, there's like other like tricks you can do. You can, post-process them. So there's like model optimizations and knobs you can change, tune on the models after they've been trained. And that's really where kind of pipeline comes in. And then we could change things on the actual runtime itself. And then all of this gets bundled into a Docker image and deployed out to any of the either SageMaker. We could go to Google Cloud ML. We can go to our pipeline cluster running on your enterprise, your on-prem. Yeah, that's actually what we're demoing like today with the Halliburton folks. We are multi-cloud as well too, so the exact same bits work across all of the 3 cloud providers. And there's a bit of work, like we do typically a 2 to 4 week jumpstart program for some of the larger customers. We can do a 2 to 3 day jumpstart program for some of the simpler use cases. Some of the simpler shops, we do that with our startup friends and things like that. So. We do encourage you, there is a lot of open source stuff. This is, we're a classic, we've started off open source. We found some really valuable parts of this that do require more cash and some VC money. So we're exploring some of these options. We're doing great with money. It's just more about the speed to scale up. So I think the next call, we actually have an announcement I wanted to make today, but I think we're going to make it next call. Someone big that we brought on, the timing didn't end up, so it'll have to be after Labor Day. But we have some pretty exciting news there, and we're pretty confident that we'll be taking this to the next level. Certainly by the end of the year, and then preparing for the kind of the January, February, the budget renewals and things that happen then. So please star the repo. We have this, kind of funny anecdotal thing about how each star is worth $1,500 to VCs. This is just from what we learned from a couple, talking to a couple folks. Okay, I'm gonna quit boring you guys with the slides. Here's the new site here. Pretty much the same as all the people that we've been working with to get to where we're at. Some news. We simplified this slide a lot and really focused on continuous training, continuous optimization, continuous validation. And then there's really a fourth, which is continuous, that's explainability. So if you hit try it yourself, we should be over here. Couple things. New things to note. So we take you right to the samples, and this is kind of a way to get you guys to just start interacting with the site quickly. You could put your tag here. So this would be just a unique tag. I'll do Chris. What did I take care of? P34. And if you notice, there's an accuracy up here. This is really continuous accuracy. This is the model that it's a sample model, but we're constantly, so this accuracy will actually go up and down as it's receiving more data. So, picture this model, these models are always in motion. And that's very different than a lot of tools that you see where it's literally just pulling the data out of a database. Our data is constantly being retrained. And the results are, we're showing snapshots. And when you're ready to actually push that model live, and so these are all the models that are out there right now, and we'll be sending traffic to these here in a bit, but we would click optimize. So it's first step of optimize and deploy. We see the environments. Now, the professional gives you access to your own private AWS, private Google, private on-prem. That's really enterprise. So these are disabled. We're just going to do it on the shared memory. Here you have options, CPU, GPU, TPU. We're just doing CPU today. And this is, these are all really the advanced features here. And these do tend to be a bit more high touch, which is why these are professional versus community. you know, just taking someone's model and running some quantization, especially if you quantize activations. These are not simple things to do. Not a lot of people like know how to do them. They are here, and as we do create and build up more and more samples of these, we will post these and show you how to, you know, really do these yourself if you want. Also, these runtimes. So here, this is a bit of a cryptic build of our system here. There's a newer one that we built last night that really isn't focusing more on the runtime, but it's actually focusing more on what we're balancing. So Python would be a good balance of accuracy and speed. TF Lite is high speed and relatively low accuracy. TF Serving is you know, high throughput and pretty decent accuracy, but really it's four different goals. So this actually should have said those types of words, but right now we're just exposing the actual technology itself. That's okay. So let's select one of them. And that's going to put this thing in progress. So real quick, here's the bandit router. This thing is, yeah, it looks like there's a bug with it now because we haven't created any bandit router. But what would happen here is you would click this, and this would have a function that would grab the latest state of all of these services if we deployed 3 of them or 6 of them or 12 of them. And it would constantly be keeping an eye on the function that we give it, knows how to take the inputs, run some function, and then determine what the next step is, right? So, and which variants should get more, which users should see which like model variants. So if you look over here too, online accuracy. So this is kind of when, yes, as this model is like living in production, this is kind of an accelerated timeline here a bit because this model is living in production and it's constantly being updated. Like I said, people can use a Spark job. You can use an external REST API to go and update this thing from your ground of truth. You can have like webhooks that are pulling it. But, you know, like really what we're trying to do here is test different variations. So when I hit the optimize here, I have different hardware selections, right, in different environments. I could actually compare Azure to Google Cloud. That's kind of the basic one. That's a pretty fun, it's a fun demo that we do. And depending on the type of instance that you provision, you actually sometimes see some really shocking results with Google Cloud just blowing away Amazon. And then, yeah, other cases. There's a lot of little subtle things that are the problem there where GPUs are network attached within Google, and they're, for the most part, on the same board within Amazon GPU instances. So there's a lot of tricks there. But like, keep in mind that, these are the models that are in motion. They're outside of the research lab, and they are, ready to rock. And then when this thing is done optimizing, we'll be able to, click complete, or actually route traffic. So this one, I would want to route 100% of the traffic. And let's give that one a little bit more time. Then you can come over here and click Invoke, and this would actually take these inputs and run it through that particular model. And what it's really doing is, for example, so here's the many different languages. If you have one in particular that you use, let's say you're a Go developer, go here, you could click this thing over there. There's a little copy button over there that's kind of cut off by the UI thing, but or just copy here, put this right into your code. I should be able to do this right from here. Copy this, take it out to boom, boom. Yeah, something's wrong with that one. We saw a problem with that this morning. So yeah, we're gonna work through that one. But the next screen here is we would actually see X and Y axis plots. So this is kind of a vacant chart right now because we had a problem upstream there with the predictions. But the X-axis will be 0 through 9. And the Y-axis will be a hashed representation of that like JSON input. And by that, I mean, this is finished. I should have applied it. Manually. See if this will work now. Yeah, okay, so here we go. So that just took a little bit to come up. So let's click, click, click. We'll see the variant that's involved. We'll see the probabilities. So, this is the confidence. It thinks this is a 7, and it's so confident that all of them are 0 except for the 7th digit, the 7th index. So this is an index array, 0, 1, 2, 3. Wherever the highest number is how they're getting to. So this is basically 100% confident that this is a 7. And if you do want to take this same code and integrate it into your app, your Node.js or jQuery, Ruby, I think there's a few others too if you're interested and you can support them. And here's that dot. So this dot shows up and it actually shows, I think this is actually, there's a bug here where it's not actually showing. So this is the hash version, and it's some, garbly-goop hash of that JSON. The reason that we're hashing it and that we don't care about the actual name is because all we want to do is group these predictions, with, and so for the same prediction. So like imagine being in shadow mode. Let's deploy one more here since we're here. Let me do these two. And we can actually get the specific predictions and the confidences. If I click on this here, I should see, so this is the image. So that's the same, and this is the variant. And this variant was Keras. See, I think this is every single prediction. Keras, Python, yeah, that's all we had. So it's just showing the 7 or 8 different variations there. So let's see if this other, so, and then all of these variants end up here, and we can press invoke, 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 and we should see them light up on top. If I click enough, you'll see the upper left is getting some traffic. And we could see latency, we could see the 99th percentile. We have kind of an overall health of all of our services. And we have circuit breakers in here, very good architectural patterns. So this tab is more the kind of validate. This is, comparing. Sometimes what's going to happen is if for the same input, we'll have a model that will be confused and will return a 1. And so that's what we're really looking for. This is only a couple bullet points. I can grab some other, in my Invoke here, I could change some things, give it different. Let's see if I can do something crazy here and put it over here. See if this does anything. I think I have other examples on disk, but let's be fun and just try to randomly do this. Okay, let's see. Invoke. And invoke. Still thinks it's a 7. Yeah, so I'm not changing it enough, but okay. And then over here on the explainability, so this is the start of our of exposing the explainability features that we have. So again, because we're owning the runtime, because we are the runtime, we're the middleware for these machine learning sort of online predictions through streams or through these web requests. We can inject other, if you want to think of like filters or add-ons or wrappers, and we can, now start to apply more advanced analysis while it's on the actual wire itself, which is right when you want to know, which is right when you need to make decisions. If this is a bad model, you want to pull it out. And I think that's it. We've got this fun little, the start of a fun little save as. So save as has always been like a funny thing that I say in my life, which is, oh, I wish I could save as and blah, blah, blah. So we threw it up here to see how people would react to it. But, really it's the ability to take the environment that you're currently working on, click save as, and choose your environment. Maybe you want to go to private. Amazon maybe want to just use a private part of community. That's an option actually. That's not highlighted there, but private on-premise. You can choose your hardware. So if I go next, it'll be this should be CPU, GPU, TPU, same as before. You're about to create the pipeline cluster. Just warning you, clicking it, and boom, it would then show up. You would have your own subdomain and put your credit card in so that we know you're not going to do bad things, or you're like more likely to use the system that way. And that would be your private environment. And then from there, you can move it into your own like infrastructure. So I think that's it. Had a lot of changes over the last month. So let me look at questions here. And wow, yeah, a lot of people stayed on. Thank you so much. Very interesting. Okay, there's no questions there, so let me look in the chat. Okay, people are raising their hand. I've got to figure how do I do this. Okay, attendee raising his hand. Switch from there to there. Okay. Promote to panelist. Okay, Jay. Yeah, do you have a question? Do you want to put the question in the chat? Trying to get you to. I can't figure out this thing here. Hello, hello. Okay, how do I do? Yeah, I'm trying to get you guys promoted to a panelist. That way you can chat. Yeah, guys, try to speak if you can. Otherwise, there's a. Here's the chat. Okay. Okay, hang on here. Not to screen. Is PI built on top of other platforms? Yeah, so PipelineAI, let me make sure I get the first. Okay, yeah. PipelineAI definitely like builds upon other projects, things that we didn't want to have to rewrite. We come from a Spark background. We come from a very heavy open source Cassandra background. Very, very familiar with Hadoop. We speak at all the Hadoop conferences, all the big data conferences. Flying back to New York. Well, tomorrow is JupyterCon, so I'll be there. And then again, the Strata conference back in New York a couple months, I think a month later. Let's see. Yeah, and Mesos, we actually just deployed on Mesos through actually Kubernetes. So the Mesos folks have a nice, clear integration with Kubernetes that actually worked quite a bit smoother than I thought it was going to work. That's actually what the demo is this week at this big Halliburton conference. For a hands-on demo, good question. Hands-on demo. I probably should have said this in the beginning because you guys could have been doing it the whole time. Go to HTTPS community.pipeline.ai. Actually, I'll give you a better one. Quick start /community. Okay, let's see what else. Can we see support level for distributed +1 at M? Yeah. PC support level for distributed GPU model optimization, inferencing. Yeah, so we do now. Do you mean is this distributed batch model optimization and batch inferencing. This is for Jay. And real-time hyperparameter support for parallelism or model parallelism. Okay, the hyperparameter tuning question, support for model parallelism or data parallelism only. So for the hyperparameter tuning, that's pretty much almost always I always get this wrong, the data parallel. Where what you're talking about, if we need to split the model up over multiple nodes, or can we copy the entire model to each node? And in almost all cases, it's brute force. It's essentially grid search, but more complex than grid search. But at the end of the day, you're just running a lot of jobs in parallel, and typically it's the same. But yeah, there is certainly support for model parallelism. How do you support exporting to these other formats? Who implements? How do you handle new architecture probably cause issues on unsupported layers? Yeah. So the question is, this stuff does start to get very systemsy, and this is what we spend our days and our nights and our weekends working through. So there was a point in time when we thought we could try to do all these things ourselves and be in stealth and just pop out, like an Easter bunny. And what we've come to realize is we're actually a lot better off by being transparent and working with, the guys from CUDA. There's some specialists out of Berkeley that know these things a lot better than us. So the best we can do, we live in the Bay Area. The best we can do is collaborate and hope people are nice and willing to share information. And but the specific answer to your question is, you can try these things, and if they don't work, you at least have ruled it out. And by trying it out, I'm saying trying it out in production, not just on your, if you do get it to work and it works in your lab, you're still very far off from getting this thing to work in production under load. And that's what we spend a lot of our time doing is, think of our research lab where we have machines set up, we have, benchmarks constantly on these types of things, and how long does it take to optimize? Is this worth it overall? Is this costly because we have to use 7 GPUs, or we have to buy, our lab has to consist of every single type of GPU that's been made out of NVIDIA. So there's a very, very high number of parameters for these hyperparameter tuning that's at the systems level that are not very well studied and not very well rather understood. So can we see the high bar demo? I'm a little confused on that one. If I don't get to your question, just ping me after. I'll get the team to look at it as well too. Very interesting, thank you. Yeah, and the GDPR stuff, yeah, you guys hit it right on the head. GDPR is driving quite a bit of our focus on the explainability. And it nicely rounds out and it sort of encourages our vision to own the runtime, to stabilize that runtime and to unify the runtime. Only without, unification in this area, there's many, sort of one-off people doing it. I was talking with someone this past weekend, a friend of mine, and he said, oh, explainability, that's like 5 lines of code. Yeah, why would I need a platform for that? And we walked through various scenarios of, how do you make sure it's done the same way between time, and what if there's a new update where you're going to put that 5 lines of code, So this is coming from a person who is more on the data science side and really doesn't have a lot of background in sort of framework building and application development and, and the pains of not using a platform. So yeah, coming from BEA, we have these conversations all the time, and it's just funny how 20 years later this stuff always comes back in a slightly different context. There is a recording. How to integrate Spark and TensorFlow? Yeah, and Yeah, how do you integrate Spark and TensorFlow? There's a couple different ways. Really the most successful way I've seen people do it is to not do it. And I'm being a little bit tongue-in-cheek, but really keep your Spark workloads doing Spark stuff and write it out. There's an ecosystem project that can get data ready and saved in TensorFlow's TF record format, and just treat Spark just like a big chunky system that can do feature engineering, right? And can do ETL really well. If you start using obscure parts of the Spark code base that are there for deep learning, you'll start to get in trouble. And really, if you're starting from scratch, what we see pretty much like everybody doing these days is TensorFlow now has a lot of data sets and maps and filters and transformers. And so TensorFlow is much more quickly extending the TensorFlow functionality to include ETL and batch. I'm going to be a bit controversial and say that I feel that adding an ETL engine is much easier than Spark going and adding a neural network engine. Just in terms of skill sets, this is more than just distributed systems. This is more than just distributed databases, more than just log scraping, more than just query plan optimization. Like these are not simple concepts, but they've been well studied and well understood. Whereas on the neural side of things, trying to address explainability, trying to reason through complex ensembles and tune which ensembles should participate in like which predictions under which certain times, right? These are all super important and rather difficult hyperparameters to simply just do with the ETL framework. Yeah, all the slides will be there. If you go, it'll be on slideshare.pipeline.ai. Hands-on demo. So the hands-on demo, yeah, let me put the HTTP, maybe cloud. Okay, clarification for online distribute for more parallel support. Simplest path forward is supporting protocols. Oh yeah. Speech for yeah, exactly. There's the NVLink. There's NVSwitch now as well too. That gives you up. I think it's up to 16 or up to 32 like GPUs. They've gone away from the mesh. Yeah, I mean that's all. If there's the Nickel library by the NVIDIA folks as well too, and this is a very deep discussion. We have to figure out what the communication pattern is and the data movement pattern within your particular like training job. But yeah, and yes, always the goal here always is to move as little data from CPU to the GPUs as possible. And there's a couple ways you could do that. You could use the modern XLA, the accelerated linear algebra libraries that are built into TensorFlow that will essentially, use its cost optimizer to figure out and to fuse together layers and make these calculations much faster, especially on a GPU. It can, think of taking 10 operations that are all combined into one single operation. Now we have to move memory once, do one gigantic operation, and then take the results, move it back, and then split up the results. And the chips and the hardware are specifically designed for this kind of stuff. Also, you would want to do things like 16-bit and half precision. That's what these TPUs really rely on as well too. Got it. Yeah, Jay, I think I see what you're saying. Across the GPU cluster. Yeah, and that's yeah, that is one of the more complex things. In fact, the TensorFlow folks have benchmarks on just their distributed setup, and that's really where the dataset API came about, and that's TensorFlow's kind of first cut at like something like data frame that Spark had. So, and the thinking there is that they're doing all the distribution for you. There's also this other project called Grappler that's within TensorFlow. That's it's a bit mysterious, but I believe it's been referenced in some of the papers where they can dynamically route around either slow networks or GPUs that have become so hot that their firmware is asking them to do less work. So yeah, there's like lots of strange conditions that can happen. If you're not familiar with them, you'll think your GPU is slow, and really you're pounding the GPU and it's trying to keep up, but the firmware has it on there to slow down, otherwise it'll melt. TPU is are 16-bit, yes. And yeah, how is the let's see, how does the performance of the 16-bit? Yeah, there's actually a really good benchmark. You guys should check this out, called Dawn Bench. It was done by Stanford. It's their new Dawn Lab, which if you're familiar with Spark, it's similar to the AMP Lab within Berkeley. So here's some benchmarks. They're showing TPUs. The cool thing is that they don't just show TPUs on training. If you scroll down, they have training costs, so that's good. But now they have inference latency, and they have inference cost. And one interesting thing is the CPUs are actually kicking ass at inference. And while TPUs were classically tied to inference, just kind of, you know, folklore that we heard from early releases, or that they were meant to be on mobile devices, and but really these CPUs end up just, you know, rocking it on that side, and you don't even see a GPU. Well, there's a P100, it's the first one, and then yeah, another P100. But and then there's, so yeah, this is really cool that this is more than just training. This is actually inference. It's the framework that's being used, you know, and so our mission, for example, to put it in kind of benchmark case or the context, is that we can actually do this entire benchmark with just a couple clicks. We can choose PyTorch, we can choose the version, we can choose the hardware, we can choose the cloud provider, we can choose the, you know, networking if it's given in here, and we point it to the data set, and boom, like we could, like in theory, right, like replicate all of these benchmarks all the time at like any given point in time. It's kind of a silly goal, but it's a goal that we definitely right, like could achieve. We could take it, we could drop it into your environment. One thing someone suggested is, if you can get to that point, or even take one of these, that's an impressive benchmark. And if you can prove to me that you can replicate that that same benchmark, that means you know, that's hugely powerful, because that means I could pretty much take any job off the street, and with just a couple, you know, checkboxes or switches within like PipelineAI, I can now be, you know, training like the big boys and the big girls, right? So the Facebooks and the and it's just a matter of provisioning the hardware at that point. So anyway, we're about 15 minutes over. Keep an eye out on I believe it's pipeline.ai/community is where all the resources go, and I hope to see all of you soon. Sorry about the background noise. I'm traveling, so I'm always trying to find the quietest place. So any other questions, shoot me a note at chris@pipeline.ai or help. You'll probably have better luck at help@pipeline.ai, since that goes to the entire team. So also, we're, you know, classic, we're hiring, and we're looking for people that think like this, that have seen these problems, junior people, senior people. We have an opening in our San Francisco incubator house, which is my house. We have an opening there. If you know anyone that can move from wherever they're at to San Francisco, wants to come in for 6 months, and we'll mentor them and get them set up with nice, $2 million home in the nicest part of San Francisco. They won't be on Market Street. They'll be actually in a nice part of San Francisco. So thanks, everyone. Talk to you soon.
So we might change it again. So right now, that's the thing I'm talking about. They always do it.
Hello. Let's use the bathroom real quick, too.